So today we will discuss two topics. One is force on a current carrying conductor, current carrying conductor placed in a magnetic field. Magnetic field. So this is the topic: force experienced by a current carrying conductor when it is placed in a magnetic field. So in this case, we will consider uniform magnetic field, and the force experienced by the conductor will find out what amount of force it will experience. Okay, so let us consider a conductor carrying current in this direction. I is the current. So when current I flows through this, electrons must be in opposite direction, and there is a magnetic field which is perpendicular to this blackboard. The lines of force of the magnetic field is considered as perpendicular to the plane of this blackboard, and strength of magnetic field is B, and charge of an electron is E. Electrons are moving in this conductor. So length of the conductor is suppose L. L is the length of the conductor, and area of cross section of the conductor is A. Okay. Then if Vd be the drift velocity of electrons, drift velocity of electrons, then what will happen? The electrons will be deviated from their original direction of motion because the conductor is placed within a magnetic field having uniform strength B vector. As we know, when charged particle moves in a magnetic field, it experiences some force. So here electrons are moving within the magnetic field. That is why each and every electron within this conductor will experience some force, and their drift velocity direction will change. Okay. If Vd is the drift velocity, then current is given as I N Vd RAE. So expression of current with drift velocity is given by this expression, this equation, as we know. Now, already we got the force experienced by charged particle. What is that force? The force experienced by an electron of charge E is given by F is equal, since the force is E, the magnitude of the force, if we write the magnitude of the force, E V B sine of theta, equation number 2. So if this is drip velocity, then you can write Vd, E Vd, E sine theta. So in the conductor, we are considering the velocity of the electron is Vd, which is drip velocity, B sine theta, where theta is the angle between VE and B. Where theta, the angle between VD vector and B vector. Now, equation 1 gives VD as I N A E, right? So, if we put, therefore, it implies equation 2. If we put the value of VD here, F is equal E I N A E B sine theta, sine theta. Okay. So E will be cancelled. I N A B sine theta. So equation number 3. Now here, what is small n? So in this equation we are writing small n. Here, small n is the number of electrons per unit volume. So small n is the number of electrons per unit volume. Then what will be the total amount of electrons within this volume? If length is L, the area of cross section is A, then total number of electrons will be equal to small n multiplied by volume of this conductor. Okay. V L into volume is equal L into A. L is the length, A is the area of cross section. Area of cross section. Therefore, volume is L into A. So if you multiply this volume by N, so N total number of electrons. So what will be total number? Capital N, V into small n. V is what? A into L. Okay. So A into L into small n. This gives the total number of electrons in this conductor. So we have, this is the force. Equation 3 gives the force experienced by a single electron. Okay. So this is the total number of electron. Capital N gives the total number of electron. Small f gives the force experienced by single electron. Okay. So net force, therefore, Therefore, net force experienced by capital N electrons. How many electrons? Capital N electrons. Because this conductor consists of capital N number of electrons, which is equal to ALN. So this small force should be multiplied by capital N. Then we'll get the net force experienced by all electrons. Let it be represented by capital F. So N small f. So small f is the force experienced by single electron. Then all electrons will experience total F force. So if you put the value of small f and capital N, what you will get? So value of capital N is equal to A, L, N, and F is equal I, V, N, A sine of theta. This value. Okay. So N, N, L, L will be cancelled. Finally, the force is I, L, B sine theta. Okay, this is the magnitude. Equation number 4. This is the force, magnitude of force experienced by all electron contained in this volume. Okay, so this expression can be converted into vector form. How? Because sine theta is already there. So if you write like this, L cross B, okay, then and this F is converted into vector. L cross B means the cross product of L and B, which can be expressed as LB sine theta. So this gives the magnitude as well as direction of force experienced by all electrons. All electrons consist, this conductor consists of capital N electrons. All N electrons experience capital F force. That is why, as a whole, the conductor will experience this amount of force according to in a direction given by Fleming's left hand rule. In this case, it will be suppose this direction, the force experienced by all electrons, combined force experienced by all electrons will be in the downward direction, which is given by Fleming's left hand rule. Okay, so all directions will be perpendicular if theta is 90 degree. So if we consider case 1, if theta is equal 0 degree or 180 degree, then F will be the magnitude of this. F will be theta is 90, 0 or 180, sine theta will be 0, then F will be 0. Minimum force. If theta is equal 90 degree, then F is equal ILB. ILB. Okay. ILB. Then this is maximum force experienced by this conductor. So we have a relation that the force, current, length of the conductor, and strength of the magnetic field. This is the maximum force experienced by the conductor when it is placed within a magnetic field. So this is very important relation because if we use this relation, we can find many results. Another immediate calculation, we will go for the mutual force between two current carrying conductors. So this is one calculation. When this is the force, magnitude of force, and this is a net force, that is direction as well as magnitude. Okay. So these two expressions are important. It's the force, magnitude of force when a conductor carrying current is placed within a magnetic field of uniform strength and length of the conductor is L. I is the current flowing through this. Then this expression will give you the magnitude of the force.